The following presentation is intended for managers responsible for employees who may be exposed to harmful levels of vibration through the use of power tools or other processes that might cause vibration to enter the hand and arm system. This is part one of a two-part series. This part one will focus on why it's important to manage hand-arm vibration and how Reactec's technology can help you to do this. It will touch lightly on how the system works, but the following presentation, termed part two, will go into a lot more detail of how the system works and how you can best use it to manage your employees' exposure. Hand-arm vibration syndrome is the overarching medical term to cover the damage that can be caused to the hand from exposure to vibration. There are three types of specific damage: neurological injuries, vascular injuries, and musculoskeletal injuries. These can result in a loss of grip strength and severe pain and numbness in the fingers, pins and needles, and a loss of the sense of touch. When looking at the human response to vibration, there is a correlation of the likelihood of developing the symptoms when exposed to a certain level of vibration. This relationship between exposure and health outcome has been developed looking at the vascular side of the possible damage only. And with that consideration, it's been said that 10% of employees exposed at the action value, which I'll explain in due course, if you're exposed to that for a period of 12 years, then there's a 10% probability of developing the vascular damage or white finger. If the exposure is as high as the limit level, then that period drops to only 6 years to have a 10% probability of developing the vascular damage or vibration white finger. Exposure to vibration is the cause of the top RID orders reported most recently to the Health and Safety Executive. The statistics here are shown for 2018. For hand-arm vibration syndrome ridders are about 43% of all of the data shown, with the second highest reported disease being carpal tunnel syndrome. Carpal tunnel syndrome is another type of damage that can be caused by exposure to vibration, but there are potentially other causes of carpal tunnel syndrome. The legal requirements with respect to hand-arm vibration syndrome are laid out in the Control of Vibration at Work Regulations 2005. They require that an employer reduce the risk to as low as reasonably practical, but also require that an assessment of the risk is carried out on a regular basis. And they also require information and training to be provided. A suitable and sufficient risk assessment of HAV exposure risk requires a determination of two pieces of information. First of all, the duration of the exposure, and secondly, the probable vibration magnitude during the exposure. And I'll explain why the term probable comes into play in this piece of guidance. So the HSE have developed a ready reckoner to help quantify the two factors of time and vibration into a singular scoring system and relate those two to two thresholds described earlier of exposure action value and exposure limit value. So any combination of time and vibration magnitude can result in an exposure point, and your exposure points from use of multiple tools in any one day can be simply added together and compared to the thresholds of the action value and the limit value. So for instance, 3 hours of use of a tool with a vibration magnitude of 5 meters per second squared will result in exposure points of 150, which is above the action value. So the action value, which is a value of 100 points, could be achieved from the use of 8 hours of a tool at only 2.5 meters per second squared. The guidance from the HSE for people exposed to a daily level of 100 points is that action should be taken to reduce that exposure, and also that those individuals should be given regular occupational health assessments. The exposure limit value, which is 400 points, can be achieved by an exposure of 8 hours to a tool with a vibration magnitude of 5 meters per second squared. That's the level at which the HSE advise no work should be done above. And no one should knowingly put anybody to work who will be exposed to this level of vibration exposure. One thing to note in terms of this point system for quantifying exposure to hand arm vibration is that the points are directly proportional to time. So as the time moves from 1 hour to 2, twice the time, you can see that the points doubled, basically all the way up the scale. By contrast, the points are proportional to the vibration magnitude squared. So in the example given for EAV and ELV, it's the same amount of time, vibration magnitude doubles from 2.5 to 5 meters per second squared. But the points go from 100 to 400 points because it's directly proportional to the vibration magnitude squared. So given the RIDDOR statistics that were presented, hand-arm vibration syndrome is an ongoing risk within many workplaces. So we ask the question, why might it be that there's a continued prevalence of this disease? First of all, the source of vibration magnitudes, or the probable magnitude to be used in risk assessment, is often questionable, particularly if companies use manufacturers' data. And the next slide will explain more on why this is an issue. Also, your risk assessment that you might carry out in advance of work being done using some general vibration magnitude number and some assessment of the likely time of being involved in an activity may not actually be appropriate relative to the work that's undertaken. And again, there's a slide to come which will give you information on how that may be the case. Thirdly, the effectiveness of the controls ultimately. The requirement on hand-arm vibration exposure management is to control your risk to as low as reasonably practical. Ensuring that your controls are effective requires a good knowledge of the situation before and after the introduction of controls. Reactec believes strongly in using data to drive the design of your controls and data to ensure that your controls have been effective. One of the largest variables in affecting exposure risk of any one individual is their competence in using a tool. And again, it can be a challenge in knowing exactly how competent someone may be at using a tool. And hopefully, again, Reactec will be able to show you how they can help you determine an operator's competency. And lastly, another major variable in the vibration magnitude experienced by any tool operator is the tool that's selected for the job, whether or not it's the right tool, the condition of the tool, but also how the condition of any consumables or bit ends used with that tool. And once again, these are variables that with static assessments or generic risk assessments or this use of single data points for vibration magnitude is very difficult to actually understand how much these factors really do come into play. So to help explain how variable vibration magnitude can be, the following graphic is data that was published by the HSE in their guidance documents. It's since been replaced by an Appendix 3, which simply lists the tools and their vibration range information. But we found this graphic perhaps more illustrative. So in the graphic on the right-hand side, first of all, we have the results of the HSE labs carrying out evaluations on 3 different tool types. And for those 3 different tool types, as illustrated with the green bars, the HSE were able to measure a range of different vibration magnitudes, depending on what they were using the tools for. In all cases, the tools were used for appropriate purposes. So in the case of the impact drill, for example, the vibration magnitude ranged from 5 up to 16 meters per second squared. The chipping hammer from 10 up to 26 meters per second squared. And again, by way of illustration, if you were to use that chipping hammer at the bottom end of the scale for 30 minutes, your exposure risk is 100 points. Whereas if you were to use it where the vibration magnitude experience was at the top of that range, then for 30 minutes, that would result in 700 points. And again, given the relationship that was shown earlier on the relationship between the vascular damage and exposure to vibration, then if you were exposed at the bottom end of the scale consistently, it would take 12 years to have a 10% probability of developing HAVS. If, however, you were using it at the top end of the scale, 12 years would reduce dramatically to only 4. Also shown in this graphic from the HSE is the declared emissions from the tool manufacturers, which is marked on the left of the green bars. Also marked on the right is the mean of all of the measurements taken. So you can see in the case of, for example, the impact drill, the declared value is very similar to the mean of the measurement taken by the HSE labs. In the case of the chipping hammer, the declared number is very much towards the bottom end of the scale. And in the case of the rock drill, it's actually off the scale. Now, why should this be possible? It's possible because the way in which manufacturers are required to declare the vibration magnitude of a tool is under a very strict and very precise lab conditions. And those lab conditions may not then be representative of how you choose to use the tool or how the tool is used in reality. I'll move on now to an illustration developed from a case study carried out by Reactec with a utilities company. The idea of the case study was to create a very detailed understanding of the HAV exposure risk in performing a very specific task. So for background, the task was repeated several times over with a number of different people, all using the same tool. The task involved excavating a hole of a particular size in a particular type of road, and this was repeated 11 times over with 14 different people involved in the exercise. The people were deployed in teams of 2 or 3 and given the instruction to share the workload of the task and to excavate the hole. Very detailed measurements were then taken, and from that very detailed set of measurements, typical or an average time to excavate the hole was determined, as was a measurement of vibration magnitude. Once the data was collected, it was then therefore easy to establish what the risk would be in carrying out the task. So the task itself carried the risk of 280 points. And therefore, if the duty holder was able to share this work between 2 people, they would believe that they would see a risk of 140 points as a highest possible value. And if you were able to deploy them in 3-man teams, then that risk would drop to 90 points. So the duty holder gained the information of this task assessment. When the data was reviewed at an individual level, we looked at what was the maximum exposure for that individual, and there was a dramatic range between them. There were a number of individuals who were well below the lowest possible risk of 90 points, and then at least 5 individuals who exceeded what was considered the highest risk of 140 points. There was even one individual who actually exceeded the risk for the task in himself. Now, why was that possible? So we then looked at the particular data for this individual, Pete, and we were able to determine that he did share the work with a colleague. So someone else was involved in the excavation of the hole, but he was involved in digging the hole for a much longer period of time than his colleague. In the video footage, we were also able to determine that his use of the tool was inefficient. So the tool was applied to the surface at an angle, which meant that the vibration generated by the tool put more of the vibration back into him as a tool user rather than into the road. So the vibration magnitude experienced by him was much greater than many of his colleagues. And that combination of factors, his skill level in using the tool, and the lack of appropriate sharing of the work with his colleague led to him being at a much higher exposure level than all of his colleagues. In fact, he's close to the legal limit of 400 points. Now, it's only with monitoring that we can actually see that type of behaviour. So this takes us on to what Reactic can offer and how this can help you with challenges of managing exposure to vibration. So the R-Link product, which is worn on the wrist, actually gives 2 assessments of exposure to vibration at all times. It collects data, first of all, based on the amount of time the tool is being used for and the expected vibration magnitude for that tool. So this expected vibration magnitude for the tool, which can be a vibration magnitude which complies with HSE guidance and complies to the standard protocols, is then used to develop what Reactic term tool exposure points, or TEP, and is therefore in compliance with regulations. At the same time, R-Link also determines exposure points based on a real-time assessment of the vibration magnitude in using the tool. So this is based on triaxial accelerometers in the watch. There's a correction algorithm which corrects for the fact that the accelerometers are on the wrist, and it corrects for the energy that's transmitted between the grip point and the wrist to give you a very good approximation of the vibration magnitude incident at the hand at the time of using the tool. So we use this vibration magnitude with the same trigger time to give you what we term sensed exposure points, or SEP. And that gives you real additional insight into the actual use of the tool. And the comparison of the two is what gives you that insight into the tool's condition, the poor use of tools, inappropriate tools, etc., etc. Now, to help clarify in terms of the operator or the tool operator's experience of using the watch, it wouldn't be possible to show them both sets of that information. So as a company, you're able to choose and preset what information they see on the screen. So in the center of the device, it'll show them either the time remaining for them to reach a certain exposure threshold, or the number of exposure points that they've accumulated through the course of the working day. A T on the left-hand side will indicate that the watch is collecting tool exposure points, and an S will indicate the collection of sensed exposure points. The coloured circle displays their threshold levels. So if they're below their action value, the green portion of the circle will be lit up. If they were to exceed their action value, the amber portion would then light up. And finally, if they were to breach the exposure limit value, the red portion would light up. Now, while their exposure is increasing, they will also receive alerts from the watch. So it will both buzz and vibrate to alert them to the fact that their exposure level is at a dangerous level, and the length of that alerting will increase with their exposure level. Finally, along the top of the display, they can view enabled watch functions. This will be set in advance depending on what the watch was purchased for and is able to do. They can also see the battery indicator there. So to summarise how you might look on using R-Link to comply with the guidance from the HSE, Reactec prefer to plan, do, check, act. So the planning stage of hand-arm vibration management is your initial risk assessments. And for your initial risk assessments, you would be looking to understand the type of tools that your operators are using and how long they're likely to use them for. Perhaps use a ready reckoner to ensure that you're not putting people at risk or to be anywhere near, for instance, that limit value. You may choose to also do some compliant measurements of the tool, but this isn't necessary for a risk assessment. What you should do is go on to monitor your employees' exposure to hand-arm vibration, and to comply with HSE guidance on monitoring, then you can use your TEP points to give you an indication of how appropriate the initial risk assessment was. To look even deeper at the topic, Reactec suggests you can then use your SEP data, and even the HSE have advised that the comparison of the SEP and TEP data can lead you to see perhaps issues that you wouldn't normally be able to see, such as an operator's proficiency in using the tool and the condition of the tool and its accessories. Importantly in all of this is that the loop is closed, and the data that you can collect from your devices, whether it's TEP or SEP or the combination of both, is used to assess that your controls that you have in place are adequate and effective. And if those controls are not effective, then you can look to improve those controls. And the cycle can go on in terms of continuous improvement of the exposure risk to your employees of hand-arm vibration. As a means of concluding this section on hand-arm vibration management, I'll bring you back to the topic of ISO standards and try to clarify some of the information that you may have seen in the marketplace generally. So ISO 5349 as a standard is the standard that defines how to carry out a risk assessment, including the need for the time on the tool and the vibration magnitude. The vibration magnitude can be determined through the use of measurement as one methodology. If it's achieved through the use of measurements, then an instrument in compliance with ISO 8041 should be used. Such an instrument is one that requires a skilled technician to be able to use, that requires a calibrated instrument and requires the accelerometers to be within 10 millimeters of the grip point of the hand. Such a measurement is not one that can be used for gathering a full day's use of HAVS exposure from multiple tools, and is therefore not useful to be able to carry out or to be able to monitor someone's daily exposure to hand-arm vibration. The type of products which can gather daily exposure to hand-arm vibration, such as Reactec's R-Link watch and other products that Reactec have produced in the past, are able to help you to assess exposure as required by the Control of Vibration at Work regulations, remembering that the loop for the probable vibration magnitude as opposed to a measurement of vibration magnitude. But it isn't appropriate to say such devices are compliant standards which are listed here. So hopefully that clarifies the topic. So just by way of concluding this PowerPoint, I will just finish with a few messages of how more broadly Reactec's roadmap in terms of technology and developments may well be something that can align with your future needs. Reactec are on a journey to gather more and more types of health risk data from the workplace into our Reactec analytics platform. So we've looked at the sort of information within this presentation available from Reactec centres, including vibration and proximity information. With vibration, there's also an ability to help people on how to use tools most effectively. And from the proximity, we're moving into broader perimeter type detection. We also have lone worker type support functionality from what we call a razor device, where you have a panic function. It will automatically detect man down, and there is a check-in, check-out functionality. Beyond this, we collaborate with third parties to allow us to display noise and dust data, and are actively engaged with other suppliers of health sensors, including cable avoidance. And again, supply it in a very consistent and useful manner within our Reactec analytics platform, allowing you to have an aggregated picture of your workforce. So as we say, the center to all of this is the Reactec analytics in terms of its ability to turn personal risk data into intelligence that you can then take action with. So all of the data is displayed in a manner which you can then see clearly the controls that you may need to put in place to lower the risk of the employees in the workplace. By gathering the data in such a powerful and automatic way, then it improves your operational efficiency in terms of the management of these risks within the workplace. By the introduction of products such as Razor, it means that real-time access to data comes into play, allowing you to see what's happening in the workplace as people are live and acted out in the working environment. And as a reminder, in all things, we look to make data that you can then do something with and take action on and record all of those actions. And you can also do this within the analytics system itself. We've had a consistent and singular approach within Reactec on how we gather what is personal data. And that's a way by which each device is assigned in a very simplistic manner to a person at the start of the working day and returned, which means that at all times as an employer, you can be assured of the availability of the devices and devices being in the right condition to be used the next day by other people. We see this as future-proofing, if you like, for your investment of being able to look to the longer term in the use of your current deployment of Reactec for hand-arm vibration, with the addition of other sensors and other future applications. So this is just a few illustrations of the type of data that's available within our analytics. So this is the live dashboard showing informational data that's out in the field. We have hand-arm vibration data, we have noise data, we have social distancing information, and then active alerts and alarms when either of these systems are calling for amber or red events. And this allows you to manage your support of individuals out in the field. The live data also comes with GPS location information. Again, this comes from the use of the Razor device, which allows you to not only know the people that are in the field that may need your support, but also where they are, and therefore who might be in the best position to support them when needed. And finally, as I mentioned earlier, the intention from Reactec is to make sure that this data is supported with your ability to record your actions and improve the performance of the data. So we have control measures and we have intervention logs, which allow you to demonstrate that you are taking action to improve the health risks that your employees are experiencing. So in summary, the key benefits that we believe you will gain from your investment in Reactec are that you will be able to meet the requirements of the regulations and also of HSE. And most importantly, you'll be able to prioritize and verify the effectiveness of your controls aimed at reducing your risk to as low as reasonably practical. And those controls will be data-driven improvements, which ensures efficiency of the work that you do in terms of design and prioritizing of your control activity. You have robust and credible data that can be used in the case of civil litigation. It has stood the test of time in terms of GDPR compliance and for the use of defending civil litigation cases. And then finally, in using Reactec's technology to manage your employees' health risks, we would suggest that you're turning a generic risk assessment into a personal assessment of what's happening to that individual. Remember the case of, or the example of Pete. In Reactec's experience and the variabilities that come into play in the use of manual tools, there is always a Pete at much greater risk than you expect him to be. And only with monitoring can you find that risk and then manage that risk. So that concludes this PowerPoint presentation. Thank you for your attention.